Knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice. Maths and physics, yeah, the future's real nice.
What's up, everybody? Alright, get Discord running real quick. Alright, there we go. I'll share my screen. Oh, I need a full scale projector. There we go. Okay, now it's working. Or it should be. Bandwidth looks okay. Nice, I'll take it. What's up? Determinant of H1, A0, HO. Hola. I love your math hellos, dude. Those are hilarious, dude. Wow, thank you for the follow. AMA Challenge. What's AMA Challenge? What's up? What's up? AMA Challenge. Ask me anything challenge? How does one challenge someone to an AMA? I need to start the AMAs again. I've been so busy with this UCLA course, but I miss the AMAs. We'll do them more over the summer. I'll have more free time. I hope. Who knows? Apparently, I'm teaching 5 days a week for the summer course. What's up, Cosmic? How's life for Uzis? What up, Seth? Your mic working? All good?
Yep.
Nice. Let's see. Today is Wednesday. I did make an announcement today in the Discord. So we have our friend Nick from Wibbly, who's created this awesome kind of like interactive geometry learning app. And he wanted to get some feedback for it. And he's giving out prizes. And I love that. So if you guys want to win some gift cards, very easy to do so. I'll show you real quick where that is. Yes, so here in the announcements, it's the Wibbly Geometry Challenge. So, very easy. Just, you fill out a little survey, answer some questions, and then go through and try out the app. It's pretty dope. This is kind of the journey. So, you just got to register, and then you log in. Let me see if I remember my account. Oh dear. Uh-oh. Oh, well, okay. If I remember my
right password.
I thought I remember my password. 1 sec. Okay, well, okay. I forgot what my password is. And then all you got to do at the end is fill out a little post survey, and then there's a raffle form if you want to get entered in for the prizes. And then there were 4 little quiz questions as you went through it. Very easy quiz questions. And so if you fill those out, you get additional raffle ticket entries. And those all equal more prizes for you. So you guys got 3 weeks to do it. Feel free to ask any questions in the Discord. The Nick is in there in the thread, so you can ask questions and Nick will help you out. And yeah, I appreciate all you guys participating and stuff. It's fun. Cool. All right. Other than that, Nothing else crazy. We're here to help you guys out with questions. I know AP Calculus was this week. So, we got a couple questions. One from Speedster. What did Speedster ask us here? What is this? It's a question from Speedster. Ooh. Some factorials and stuff. Good morning, Shari Singh. Good morning. I'm sorry the chat screwed up last time, Shari. I saw your messages afterwards. I don't know, it messes up sometimes.
With someone that asked something yesterday that we did not get to, right?
Oh, who asked something yesterday? Do you remember? Was it the PDE questions?
You said.
Oh yes, that is AMA. That's his name. AMA is awesome. That's him. Okay, that's who AMA is.
You said.
Yeah, I got it. Okay, cool. All right, here, let's start off the stream. Help you guys out. Welcome to an office hours, meeting stock goals, sexual education, stream helps you with math and science homework.
Nice.
All sorts of fun stuff. Roblox gift cards, yeah. If you want to win Roblox gift cards, I'll count them. Nick's giving out the gift cards, so I just told him anything that's not like basically a Visa cash card, so you know, buy things hopefully that are kind of education related or gaming related. But yeah, whatever you guys want. If Nick can get it for you, he can get it. If he can't, I'll try and get it for you. But okay, cool. Let's see. Does equity here? Equity. You want to start from yesterday's questions with AMA?
No. You said that you didn't get to yesterday. That you were doing it to today. That you said on stream.
Which ones did I say? Was it?
I don't.
I think it was this one. I think it was the length of the curve.
What?
I think it may have been this.
Which is where?
It's in the web help screenshots.
Okay.
And then this one as well. I think these were both from AMA.
Okay.
What's up, Recky Rec?
Okay. And that was
What happens if you reach the follower girl? Are we close to our follower goal? What is it? Are we very close?
Oh yeah, it was the happen areas.
Oh, we're only one away. That's really cool.
Remember that?
I don't know. Do you guys want a pizza party or something if we get to the follower goal? What do you guys want?
And we got 4 for today, at least.
Sir, did you know that the gold color of gold can change into many others colors like red and pink? I did not know that. That's really cool though.
So,
one sec. Let me fix this. My network stuff's doing weird things. One sec. Let me open my network settings. Okay, there we go. No, still losing half. Why am I losing half my frames? Twitch. Why you gotta be so mean to me, Twitch?
So we got a lot. We have 4 trig, 1 exchange rates thing, and then we have 1 tat plus 1.
Okay,
At least
let's
the
do it.
turret.
All right, I want to try this
start
one.
with the tat plus.
Yeah, the arc length one. Let's try the arc length one. I do not know why. I don't know why. Okay, whatever.
Sorry, 5 trig.
Twitch is dropping a lot of frames. Okay, to the integral. It's t equals 0 to like.
Hey.
What's up? Oh, AMA wants to come speak. What's up, AMA? What's up, dog?
Yo, I woke up. Yeah, I literally woke up so I can watch you.
Oh, that's super cool.
So,
Wow, he woke up just so he can watch it. Where are you watching us from, by the way? What far distant land are you in?
Egypt.
Egypt.
That's dope.
Yeah,
Wow,
it's like 3 a.m.
We got a legit Egyptian on the stream right now, waking up at 3 a.m. Okay, that's cool, dude.
Yeah.
Do you want me to do this one for you? Do you want me to do the arc length one?
Yeah.
Okay, let's do it.
Sure.
Okay, so I believe the equation for arc length is from like some parameter t0 to some final parameter t1. And then it's the square root of 1 plus f prime of t squared dt. I believe that's the arc length equation.
I would that easily. It wouldn't hurt to check it.
Yeah, it's the arc length formula with calculus. Yeah, this is it. Okay. Yeah, this is it. Okay. Okay, so we're cool. In this case, yes. Yeah, the issue here is that it is parameterized. Jeff is super correct. Yes. Now, I think it's dx dt squared, then dy dt squared, Jeff. Is that correct? Right. So this would be if something was just a function of t. The issue here is that x and y are both functions of t. Okay, AMA?
A problem why, then?
Yeah. This part right here.
Right.
Right, okay,
Are
good.
those two separate functions? Or are they the same
Yeah, well,
function?
because x describes the x coordinate, y describes the y coordinate. And then,
Yeah.
so what you end up having to do is this has to be dx dt squared plus dy dt squared. And now this is dt. This is the formula if it was just like, for instance, it was just y of x. If it was just y of x, this would be from...
like you solve it using the parametric equation. Like you got the first derivative with the
Oh, okay.
parametric way.
Yes.
Okay. So then you square the derivative and then you solve the integral and then part c. You know.
Correct, but you have to do it for each one, right? So you have to do dx dt and dy dt.
Yeah, so it's like dx dt. I think the formula was dx by dt.
Yep,
over
that one.
No, dy over dt over dt dx.
Oh.
Or dx dt.
Oh.
Yeah, so like look up parametric derivative. Yeah.
Let's do it. Let's look it up. Let's look it up.
So yeah. Okay.
This just says it's
No.
dx dt dy dt.
Yeah. Okay.
I know what you're
can
thinking
do
about.
that.
You're thinking about the chain rule, is what you're thinking about. Someone says you. Yeah.
need
So
chain rule.
yeah. Here's the interesting thing. You could have factored out dx dt squared to get the 1. This is actually really cool how this works.
The derivative of e and derivative of 1 plus sine t.
Yeah. Okay, so let's just do it the simple way. Okay. And then we'll see if we can parameterize it and do it the other way, because I am curious about that, actually. Okay. So dx dt is just negative sine of t. So this is a square root
Jeff,
of...
what? What did Jeff's talking about?
Yeah, Jeff's talking about another way you could do it.
T.
Yeah. So this is going to be sine squared of t, AMA, right? Plus
Yeah.
cosine squared of t, right? Because that's the derivative of dy. Is cosine squared. And then this is dt. And then sine squared plus cosine squared is just equal to 1. Isn't that dope?
That was... So what?
So it's the integral from 0 to 2 pi
Two over 1.
of the square root of 1 dt, right? So that's
which
just
is-
going to be equal to 2 pi. Okay. Not too bad. Okay, but now where it gets tougher. We're saying if the part of the curve described in part B is rotated about the x-axis, find the area of the generated surface. Someone says draw it on Desmos. We could draw it on Desmos. You want to draw it on Desmos? Let's do it. It's a perfectly valid thing to do. I agree with that.
Anyway, I'll send you something in help screenshots. Okay.
Yeah, do it.
It's not a question. It's how to solve.
Okay. dy over dx is dy over dt.
Oh wait, but
over
how,
dx over dt.
can you use Desmos to graph this parametrically? Can you?
Yes.
How do you do that?
You have to state. You have to state as point as. It's weird. Is it?
Oh, you mean
As
like a
an X point and a
vector?
Y point?
Do I have to do this? Oh, I think you're talking about Seth. Okay, there we go.
I don't know what I'm.
Yeah, like that, right?
I'm doing a little line there.
I think
Is
that's
it
it. Yeah, it's a little curve, right? And I went from 0 to 2 pi. Oh, it's just a circle.
Surprise with the radius.
Surprise!
Of the radius though. What's the radius? It's not a circle.
The radius is 1.
It's not a circle, is it? The unit circle.
Mm-hmm. We just found the circumference of a circle.
Good job.
Good job, everybody. Yes. So, yeah, AMA, what you're talking about, your solution. This is cool as well. Okay, so let's just remember, right, that in general, if you go from like some general parameter like t0 to t1, yeah, it was equal to dy.
Yes.
What was it? dy dx squared. No, sorry. It was dx dt squared plus dy dt squared. And then it was dt. You could pull out a ddt from both of these, I think, right? Or how do I want to do this? Let me think.
Yes.
Oh, well, I want to pull out a dx
dt
dt from ETH. Wait 1 sec. This is the same
This
thing
is
as
the dx
t0 to
squared plus dy
t1
squared.
of this is dx dt, and then it's times the square root of 1 plus dy dt squared over dx dt squared, right? dt. I just factored out a dx dt. And then dx dt dt, like combining these two, that just gets me dx. So now this is the same thing as the integral from x equals x0 to x equals x final of the square root of 1 plus dy dt squared over dx dt squared. And is that just dx? I think it is. Yeah, Twitch is dropping some heavy frames. It'll even out eventually. I don't know, for whatever reason Twitch is like Twitch eventually settles out. It's always like rough in the beginning, and then it like stops messing. 1 sec. Let me fix this for you guys. 1 sec. Okay. It should connect. There we go. Tell me if Twitch gets better. Yeah, okay. Tell me if it's better now, Jeff. Might be a higher latency, but I think the stream quality should be better. Seems okay. Okay, cool. I don't know. It's an OBS bug is what it is. I have to like stop the stream and then restream it to an RTMP server or whatever, and then it works. Nope, he says bad again. Okay, whatever. Gio says, I'm stuck on this Algebra 1 question on my younger sister's homework, and I'm not sure how to solve it. Well, if you want help, go down there to actualdiscord.com/submit and submit a screenshot. We'll go through it. Is AMA still here? Yeah, he's still here. Okay, cool. Okay, do you see this, AMA, how this works? How you can also say that, like, dy over dx is the same thing as dy dt over dx dt? Because, like, the dt's cancel. So now this is the same thing as x goes from x naught to x final, square root of 1 plus dy dx squared dx. Yeah. Okay, cool. So that's where that also comes from.
So you have part.
So what were you going to say, Seth?
You have a part B on that one.
I do have a part B. Well, part C. Sorry. Okay, cool. It says if the part of the curve described in part B is rotated about the x-axis, find the area of the generated circle. Okay. Well, we know
The
from
generated
Desmos. This is hilarious, right? No, we already know how this is going to work, right? Wait, rotated about the x-axis?
Yeah, no. This isn't Guess someone.
Wait,
It's gonna be
what is
here,
rotating
right?
this about the x-axis mean? What? Like flipping it over the x-axis?
Think about it. Rotating about it. So when you rotate about an axis, it's
You get a donut. Do you see
3D.
that, Seth? We get a donut.
You did a 3D geometry.
But it said, what's the area?
What's the volume?
No, it says find the area of the generated surface. Part C. Okay. Because, okay, I think I see what's happening here. So, if you're rotating a curve, let's say you're rotating a curve this way about this axis, you could think about adding a bunch of different discs, right?
But that will find the volume. So the disc is a circle, so you'll find a volume.
Yeah. Let me think how that
You know,
works. Yeah,
the
right?
Surface area.
Yeah. Do you see how you just add like a bunch? Well, wait, we're rotating. Yeah. We're just adding like a bunch of these things.
Adding discs of areas and give you volume.
Mm-hmm.
You don't want volume.
Yeah. Okay. Oh, it wants this. Yeah, well, okay, so the surface area is just looking at the edge. So the surface area would be the integral from x equals x naught to x equals like x final. And then that would be 2 pi r. And then dx. But then I feel like you have to multiply it by the arc length. I feel like it's the square root of 1 minus dy squared over dx squared dx. Because I feel like this is like the little bit of the arc.
Jeff is saying no to what you're doing.
Oh, he says the rectangle is tilted. Oh, so you need dx. Okay. Okay. Yeah. Oh, I had it right. Okay. Yeah. Yeah, because the issue here is that when you try to do like the 2 pi r. Sorry. Stream delay is killing me. I know. I'm sorry, dude. And this is r. Then this part is no longer a dx term. It's a ds term.
It's the radian.
Yes. Okay, so this is 2 pi r, and then it's the square root of 1 minus dy over dx squared dx. And this is kind of like, this is like the arc term of it. Cool.
We already know that, right?
And we do. You're right. We do know that, right? So this whole thing right here was all just equal to 1, right? But now my y is something different, because my y is equal to 1 plus, was it cosine of t?
No.
1 plus sine of t. And then let's see. Am I still going to integrate from, according to Desmos here, I think I'm going to integrate from -1 to 1, yeah?
Do we know that, though?
Well, I think that's like the furthest point this way and the furthest point this way, right? Well, because it's really this.
We know that.
That's what it is.
We don't have Desmos when we're solving this.
Oh, well, okay. We know x is equal to cosine of t, right? X equals cosine of t, yeah?
With respect to d.
If x
would
equals
go with
cosine
that.
of t, then x has to go from -1 to 1, right? From -1 to 1. 2 pi 1 plus sine t times 1 times dx.
It is an interesting way to do a unit circle.
Wait a minute.
Just
Wait a
put a
minute. No,
unit
no, no,
circle
no, no,
as
no,
a-
no, 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 no.
What?
Sorry.
You lost your x.
I lost my x because this needs to be in
In terms of
dx. Fuck. Oh no.
E. Not an easy fits on that front, is there? Where's your x at? It doesn't exist to begin with. Is this in terms of dt or dx?
It's supposed to be in terms of dx.
Then it's 0. And it's impossible.
Well, it's not impossible, but
Well, I mean, it'd be that term standpoint 0. 'Cause it'd be
now wait a minute. Yeah, here's the weird thing, right?
the
Is
first
that
point.
I get what shape this forms. I mean, this forms a donut, right?
We need the surface area of that donut.
I need a surface area of the donut.
Ask yourself what happens when t changes a little bit, what the height and width is of the rotated rectangle.
Yeah, I'm not picturing it as a rectangle is the issue. I should be. I'm just trying to picture it like a piece of macaroni. I can't even fucking draw it. God damn it. Okay. Okay, so let's think here. So as t changes, right? We're starting to like. Sorry, let me make a new graph of this. This is my thing, right? Yeah, it's like a cylinder that's bent, is what's weird. I feel like I just want to do this. Oh, it's such a weird shape. Yeah, it's a donut without a hole. Okay, so sorry. The 2 pi r, that picks out, for instance, like a certain point here, and then it rotates it around like that.
Well, 2
right?
pi r. It's the term that isn't anything. Doesn't have anything that makes it a point. But it's not. Okay.
Yeah. Yeah, he's saying if we were rotating this way, this would be dumb easy, right? But instead, what we're doing is we're a holeless donut. Holeless donut. Yeah, it's this. Can this load, please? What's up with my internet? Excuse me? Nothing wants to load right now? Mm-hmm. This is kind of like what we're trying to figure out. Do you see how like the cross section of this thing, right? It's this, and then like it's rotating around. It's a horn torus. Yeah. Yeah. So what I'm doing is like I'm taking. Do you see how I'm taking this, right? And then I think I see. I think I see what's happening. Okay. Because we're doing like the opposite of this, the 90-degree flip of this. Sorry. We're doing this. Let me rotate. Yeah. Okay. This is what we're doing. Because as I go, so okay, and then T maps out this. Right? T is like an angle, right? This is like the angle T. And then what I'm doing is I'm mapping out
The points x and y being cosine and minus sine t.
Oh, look at this. Do you see that? Okay. I think I want to do the integral from 0 to 2 pi because I want to do these
Angle.
and I want to like keep going around, right?
So 2 pi ry, and then the 1.
Okay. And then it's going to be 2 pi and then whatever the y coordinate of this thing is.
And then what's r? And then r is the...
Well, r is the y coordinate, right?
No.
This is like
y
r.
is a coordinate on the... No.
Y is
Well, that's not
R-
y,
R-
though.
r is in terms of the curve here, in terms of this parametrized curve, it is y. This is the y coordinate. Right? So this is r. And then the issue is the dt part. Because I see. And then what I want to do is I want to multiply by like the distance from going from that to like another. This is like t plus dt. And so I need this, and this is ds. And that's like the bit of the arc. Okay. So and that's equal to, okay, one sec. I think I got it. I think I got it. Do I have to take the derivative of that though?
We already have that. We already have the piece, though.
No, we have the full thing. Oh, okay. Yeah, wait, sorry. I think you're right, Seth. ds is equal to the square root of 1 plus dy over
and
dx.
2 pi dy dt is the height of the is the length of the rectangle to Jeff.
The length.
2 pi y dt. That's there's that.
Okay. Wait one sec.
Derivative integral of 2 pi r.
I need ds, which I think is.
We have ds, which we defined, didn't we?
Didn't we?
Is the square root of 1 plus that derivative squared is based on earlier.
Wait,
pieces.
and this is 1. What? So, my ds can't
That's
be 1.
defined as 1 based on.
God damn it.
Yeah, and then what is r? So sine t. 1.
Yeah.
No, sorry, r plus sine t.
Sorry, let me see this. Okay, no, I was right. Yeah, ds is the square root of 1 plus dy dx. But I don't want it in terms of dx.
We already have that though. That's just 1. We're done.
Yeah, no, but then I still have dx though. That's the issue. So ds is still equal to this dx, which is equal to 1 dx.
Ugh.
Okay, but I think I see what I see what I want. Watch this. If I want to convert ds into like dt, so ds is equal to 1 dx. Okay, let's remember that x is equal to cosine of t, right? So dx is equal to negative sine of t dt, right?
Okay. So ds on negative sine t.
So there we go. So ds
Is negative sine t.
is equal to negative sine t dt. I think we're good.
There's what we got.
That's what I wanted.
Now we
okay.
can do this.
So now, okay, yes.
Integral, and then R is defined.
So 2 pi
what's
integral.
R is defined. Yeah.
Yeah, so
Or
R is
2 pi.
defined as 1 plus sine of t. Yes.
No, I don't think. I'm not hearing that right. What's at the end before you confirm it? What's on the problem before you confirm that? Remember it is 1 minus.
No, I think it's 1 plus. It's 1 plus.
Okay. Plus.
You're good.
I'm going to confirm.
No, I appreciate. Check, then verify. Trust, then verify. What's it called? I forget. All right, so this is 1 plus sine of t. And then ds is now negative sine of t dt. Right?
Hey.
Okay.
Let's not use our favorite. Let's use chain rule on this. Let's use chain rule on this, not product rule. That'd be fair.
Well, no. This multiplies. So this is 2 pi.
That's what I'm saying. Did you read it? Let's use chain rule, not product rule on this mess.
Oh. Are you going to say that this is equal to u?
Multiply everything out.
I'm going to multiply everything
No.
out. Okay, whatever. I'm going to multiply everything out.
Let's use chain rule rather than product rule. Because if we multiply it out, we can use chain rule instead of product rule.
How can this be a chain rule?
No, not in this.
Oh.
Yeah, not in this.
It's
case,
okay.
but
Yeah, Jeff's like, yeah, you can't use the chain rule. This is
Chain rule's always.
Chain rules. There is
Derivative.
kind of like a chain rule for integrals, but it's like reverse chain rule. It's basically u sub.
There's always a version of chain rule. The derivative is 1.
Yeah. So
That's
okay,
the chain rule part of it. But
Okay.
yeah, it's
we can do this.
separate version.
So the integral of sine
is it 2?
is the integral of negative sine is cosine, right?
Why is there?
Sorry, 0 to 2 pi. 0 to 2 pi. My bad. Okay. So this is an easy integral to do, right? Because that's just cosine. So I have 2 pi
We have to put this up though.
cosine of t from 0 to 2 pi, but that's an even function, right? So this is just 0. Yeah, right? Cosine of 2 pi is 1. Cosine
Is it?
it's the same shit. Yeah. Oh man, is this gonna go to 0? I'm gonna be really sad if this goes to 0. Oh, it doesn't. Okay.
2 pi is right now waiting for the rest of it to.
Okay.
2 pi
Okay.
is being multiplied by this thing that we're.
2 pi
So,
times the integral from 0 to
then
2 pi. And this is the hard thing. 1 minus sine squared of t. No, sorry, just negative sine squared of t. I think we have to use a double angle identity here.
Because we don't know derivative.
What the
of
fuck's the
sine,
double
we don't
angle
know
identity?
derivative of a square.
T. What's a double angle? It's like 2 sine of some fucking shit. What is it? Sine.
I have it. I know it. Actually, 2 sine.
Okay, what is it?
Cosine. I know cosine. Cosines is the.
No, no,
sine mu cosine.
there's a double one for
Formulas
sine.
With me.
There's a double one for sine. What's up,
Give me a
Infinity?
second. I have the formulas with me.
Okay, he's
I
got
have
it.
the formulas with me.
Hold, please.
I have it on the page because I used it a lot. Sine
Okay,
of
what is
2u.
Okay, sine of 2u.
You can start right. Is 2. Oh, I was the right one. Sheesh. Is 2 sine u cosine u.
Well, I don't want that one. Is there another one?
That's the one
With
you
sine-
asked for.
No, I
That's
want the
one
one with
you
sine
asked for.
squared. There's one with sine squared.
There's not, based on my stuff.
What?
There's
What's
the
up,
sine
everybody?
squared plus cosine squared is 1.
Okay.
There's the sine squared plus cosine squared is 1. You want that? There's not a double identity for sine squared.
Oh wait, really? Put identity twice. Oh, there's this one, dude.
Unless you're,
I want this one. I think I want this one. It turns into cosine
Two
squared, but
sines-
that's okay.
I don't have that. Sorry. I have sine squared plus cosine squared is 1. And I have
So there's
sine of
this.
2u is 2 sine u cosine.
So this is the same thing. So sine squared of t is equal to 1/2 minus cosine of 2t over 2. Okay. So this is 2 pi integral from 0 to 2 pi. And then the minus of that, so that's going to be cosine of 2t over 2 minus 1/2. I distributed the minus sign. Yes, Jeff, you could use the Euler identity. I know you could. Okay. You have memorized all these formulas. Good for you, dude. This is where it's kind of like a reverse power rule, reverse chain rule.
Can we move one? Can we do one thing first?
You want me to pull
for
the
one
1/2? You want me to pull the 1/2 out?
Yep. Because we can divide
Let's do
the
it,
1/2 by 2 pi.
Goodbye, goodbye. Wow, 75 people on YouTube. What's up, guys? Yo, if you want us to do us a big favor, all you YouTube people watching, can you please like subscribe or hit like or something? That would be really awesome. It really helps out the channel so that we get more exposure. We're a nonprofit. We help everyone with just math and science questions. So your subscriptions and stuff mean a lot. Okay, so it's pi times 0 to 2 pi cosine of 2t minus 1.
Of cosine 2.
Good.
Do we need the -1 in order to do something, or do we want us to split that off?
I can split it into two different integrals. It's two different integrals, but I'm just going to do it concurrently.
Do we need it for a... Do we need it for something? No day.
Yeah, watch.
And also
So,
state dt.
the integral of this, yeah, and then dt.
Before you do that...
Amiibo people can buy exclusive membership.
Disqualified.
No, we're not a pay to play. No pay to play. This is 1/2 sine of 2t from 0 to 2 pi. And then this is minus t from 0 to 2 pi. And then this is all...
And where's the two? Where's your all multiplied? Yep.
all times this. Sweet. Okay, this is going to go away, though, right? Because the sine of 4 pi and the sine of 0 is the same thing. Because of this. So we're just going to get rid of this. This goes away. Okay, so then... So this is okay. So then... Well, I'm kind of mad that the... Well, no, I don't like the answer being negative, but whatever. Okay, fine. Okay. So we get 2 pi squared.
It's not.
Is that the correct answer?
Negative 2 pi minus 0, which is negative 2 pi.
The minus kind of worries me.
Negative t. The minus is the problem. Since we're minusing, the expression of for is 2 pi minus 0, which is negative 2 pi. Of radius 1.
Well, it's not radius 1, though. It's technically radius 2. Okay, it's pi squared. Oh, no, that's LinkedIn. So, the surface area of a horn torus is 4 pi squared r squared.
With r being 1, so that's 4 pi squared.
Is r's radius 1? Yes.
Radius of the cross section r, so that's 2, sorry.
Oh, so we have 2 pi squared.
Cross section.
Fuck, we're off by a factor of 2. No.
Disqualified.
Shit.
No, we're not. More than that. More than that. Or more than that.
No, because it's 2 pi squared.
No, listen to me. What's the Tretson again? Radius of the cross section. Radius. What's a torus look like in cross section? 2 circles.
Correct.
So the radius of cross section is 2. For this is actually 16 pi squared.
No. But I think little. Oh. Where radius of the cross section r. Yes. Okay. Wait. So we're okay then. I think. Because our radius is 1/2. Oh right.
Why
is it? No, it's not 1/2.
We get the same thing. We get unit circle. 2 unit circles.
So okay. So yeah. So it is 1. This is 1.
We get a factor of 8.
No, we're still off by a factor of... No, because it's still this.
2 squared is 4 times 4 is 16. 16 pi squared.
Wait. No. But little r is 1 and big R is also 1. Because big R is the distance. Well, for this formula I do, Seth. For this formula I do.
We need to find.
That's all we're on. We're just off by a factor of 2. Where's our factor of 2?
Can I show you? You want me to show you? Nope. Nope. That's not it. But I spotted it.
Femvox says, I think Pop. Man, we're so close on this one. X equals cosine t dx is negative sine t dt. Cool. So that's it. I wonder if ds is supposed to be positive, Seth. Like, I wonder if we were just supposed to force this to be positive. Like, maybe we're supposed to do this. Would that make sense, Seth?
Don't know how it would.
Well, because ds is the arc length. You can't ever have the arc length being negative. So here, I'm gonna do something cool here, Seth. Let's just do it from 0 to pi, okay? And then let's multiply it by 2. Why does the stream lag sometimes? I don't know. Go ask my internet provider. Or someone help me fund like an industrial business line. That's what I need.
That's probably no, because he isn't stream tomorrow.
I do have a stream tomorrow though, technically for AP Physics 1. If you're asking AP Physics 1 questions, Equity, I'll do them.
That's correct.
Yes. No. DS is equal to 1 dx. Yeah, that was the issue. DS is equal to 1 dx. And then I wanted it in terms of dt. Right? You think ds equals
DS
dt?
equals dt says that. We did try to prove that, but you were integrating with respect to dt.
Wait. Oh, yeah, you're right. Sorry, ds was equal to 1 dt. But wait,
Oh,
is
there you go.
ds
That
also
fixed it,
is
right?
ds also equal to 1 dx? Is that also true?
Is it? They can't each other, can they? Can they? So that's a solve, right? So that means that's a 1 instead of a messy form.
dx. Okay, yes. You're right. Sorry, ds was 1 dt. You're so right.
DS is 1. That's gonna solve it, right?
Yeah, sorry. Yeah, this is not 1. My bad. It messed up because I was looking at this. Yeah, this is dx dt squared plus dy dt squared, and then it
Which
was
the formula is 1. Yeah.
and then it was dt. So this
Which
ds
is 1
is equal
dt.
to ds is equal to 1 dt. Okay, cool.
Which
So
then should fit.
okay, so then this goes away. Okay, we can just get rid of all this shit.
Other than this means
All right, sorry. This
this is a lot easier now.
so much easier. Okay, Shantrix. We'll see you, dude. Okay. Happy thoughts. Sorry, I was getting really confused with dx and dt and everything.
Integral 1 is 1.
Okay, so that's 2 pi
Much easier.
t from 0 to 2 pi.
Integral 1 is 1. There we go.
Minus cosine of t from 0 to 2 pi. This is 0,
Lovely.
right?
So
So that equals 4 pi squared.
the other part, 4 pi squared. Woo.
Wow.
Imaginary numbers now, right?
Oh my god, dude. Wow, that one took forever.
Now for the other half. Imaginary numbers.
Oh, well, let me do someone
Trig
else's
functions.
question. Let me do someone else's question just to like give a little fairness in the time, because this did take a long amount of time to do.
Yeah, it can. It will. We did
Yes.
that.
We'll try doing this one in a bit, AMA, if that's cool. I appreciate you
Sure,
waking up.
Sure.
We created our
Share
own
the photo
problem.
with
We
AMA.
did. We
Share
What's
the
up?
photo with AMA.
Mm-hmm.
Share the photo with AMA so he'll have the word.
Yeah, let me do that. That's a good idea.
He's no longer here. probably 24 to 5 minutes ago.
We were having too much fun. Jeff was talking to me about like curved rectangles and things. Jeff loves curved.
Okay.
Jeff loves
That
math.
was like an hour. Beat Surge problem was like an hour problem.
Okay.
It's
What's up,
3 parts and it's
Equitan?
tactless. It's tactless with series.
Okay, let's try and do this one. I do love curved rectangles
Roofing
like
problems.
Wyoming. What? Do we have any
So
web
what's the-
screenshots that have come in? Dr. Pickle Juice has thrown one. Okay, cool.
Tactile twiddle problem.
All right, thanks. Okay. All right, let me do this one for
Yes.
equity.
There is a physics problem. A physics problem doesn't look bad. Doesn't honestly look bad.
One sec, let me tag equity again. Just to make sure equity's coming around.
If you want to look at it before you move to this one.
Yeah, I see it's the roller coaster. That's a good one. The roller coaster is
Yep.
a really good one. And then usually it's asking like what's the coefficient of friction or something.
You might get to that one.
Okay, whatever. I'll just start this one. I'm sure equity will show up. All right, find all solutions. So for negative pi
From negative pi
to 3 pi of sine of 2x minus square root of 3 over 2 is equal to 0. Okay.
let's start with something simple. Let's add square root of 3 over 2.
Let's do it. I
Both
agree.
sides, and then do triangle identity.
Let's
And
add
then
square
do
root
our
of 3 over
identity
2 to both
problem.
sides.
Identity.
Let's do it.
And then let's do identity for sine 2x, because we know that. Or do we even need it, to be honest, for this?
So yeah, what I usually like to do here, Seth, is I'm gonna call this thing like box or something. We'll call this something. Okay.
Yeah.
And I need the sine of some angle to be equal to the square root of 3 over 2.
Something.
So let's figure out like
So
where
the
that
inverse
is.
sine of something.
Yeah. Well, let's see like on the coordinate plane where that would be, right? So if the sine was square root of 3 over 2, right?
Yep.
That tells me it could be this 60 degrees basically.
Yep. This.
This is 60 degrees. Or
And Jeff has a generic.
good, exactly. Or Jeff is totally right. It could be this one as well. So it could also be this one being 60 degrees, which would give me square root of 3 over 2, 1/2 and 1. Okay?
And that would be, and that is not 60, but it's what?
And that's not 60 degrees. That's the reference angle. That is a total
That's
angle
120.
of 120 degrees. Bro, because like, you know, whether it's sine or cosine will determine whether it's like this one and this one, or it's this one and this one. Yeah, so I just like graphing it.
But here's our thing, though. We don't want either of these. Both of these are wrong.
Exactly. I want them in radians, right?
If they're double of what they actually are.
We'll get to
So
that.
you
We'll
have
get to that.
this.
So I want this to be, let me put this into radians first. So this is pi over 3 plus or minus 2 pi n. Okay. And then this one, and then I can go around another 360 and another 360 and then another 360.
I like to go backwards, too. Yep.
Or we can go backwards. Okay. So that tells me right away that the sine of this boxy thing, right? It tells me that, okay, so box has to either equal this or it has to equal pi over 3 plus 2 pi n. Okay? And now I can just get rid of the box. So now if we divide everything by 2, I get that x is equal to 2 pi over 6, which is pi over 3, right? So pi over 3
Pi over 3. Yep.
plus or minus pi n, or x equals pi over 6, plus or minus pi n. And now what we have to do is just figure out like what's in the domain of this. So this is really just, at this point you're just plugging and chugging, right? Because
Okay.
for this one, for example,
let's make a point then.
so you have pi over 3. That works, right? And then
Pi
you
over
have
3,
you have 4 pi over
7
3.
pi over 3.
Do you have 7 pi?
pi over
You do have 7
3.
pi over 3.
I'm gonna keep going until I get to the one I have to stop at. 10 pi over 3. Whoops, too far. Can't do that.
Right. 10
And
pi
it
over
stopped. 10
3
pi over 3 is illegal.
words.
Negative 2 pi over 3. Negative 2 pi over 3. And stop.
Negative 5 pi over 3, right? Oh, no, you're right. We can't go past this.
Nope, stop.
No. Okay, so we have to stop. Okay, cool. We're gonna have like in between ones, right?
Pi over 6. Pi over 6.
Yeah, pi over 6. 7 pi over 6?
5 pi over 6.
No,
5
isn't
pi
sev-
over 6. Oh, sorry, 7 pi over 6.
7 pi over 6, right?
7, thank you. You did. 7 pi over 6. 15 pi over 6.
13.
And a ladle. No, 7 pi over 6. It's not 13 pi over 6. Is it? Oh, yeah, yep. 19
You
pi over
good.
6 is then a ladle.
Yeah, this one's wrong. Because 19 pi over 6 is over 3 pi,
Can't do it
which is 18 pi over 6. Okay, but then we can go backwards. When we go backwards, what do we get?
Negative 5 pi over 6, and then stop.
Uh-huh. Cool.
Let me stop.
Okay, so like now we do putting it all together. Putting it all together. The lowest one I think is this, right?
Yep.
Negative 5 pi over 6.
Yep.
And then negative 2/3, negative 2 pi over 6. And then I believe pi over...
No. We don't.
Yeah.
No. That's
No,
not
negative 2
right.
pi over 3. Uh-oh.
We don't have- There you go.
Sorry.
I did it.
Okay, so then it's pi over 6. Pi over 3.
You'll see a
7
pattern.
pi over
You'll start seeing
6.
a pattern.
I do. 13 pi over 6.
How we're gonna write that?
And then 7 pi over 3. Okay, very cool. Wow, that's a lot of them. That's pretty crazy.
And then state. It is state something.
And then what, sorry?
Those are numbers. Those don't mean anything.
Oh, I mean, that's what x equals, right?
You didn't say that.
Oh, I did it now.
There you go.
Good job.
Okay, cool.
One more. There's one more in that photo.
There's one more in that. Okay, well, let me save this because this is all of the first question. What? Oh, yo, what's up, Skeeg? Sorry, I'm getting. Let me give.
Now some fun. Now a more interesting one.
Good morning.
Good
Good morning
morning,
to you too, Skeeg. Skeeg must be in like Skeeg. Where are you in? You in like Hong Kong, or Taiwan, Taipei? Those look like Chinese characters to me. I feel like they're Chinese. They could be Japanese, maybe? No, I don't think they're Japanese. Taiwan. Okay, cool. Freedom, China.
I feel like the next one's gonna be a little bit neat.
Okay, let's see. Oh.
What's neat? And I might form a sheet. I
According to
see it.
DeepSeek, Taiwan is not a country. It's true.
Nice. Yep.
Have you seen that,
Are
Jeff,
you
though,
sure?
where you can trick DeepSeek into spelling out Taiwan? You, like, give it, like, a code for things, and then it starts, like, writing the numbers out. Okay. Let's try this one.
So we have this.
So we
Yeah.
know an identity for this,
Okay.
right? What was the identity for this one?
Before I do that, I'm not gonna state the identity. Let's write it out and fits this thing. 'Cause it doesn't look nice right now either.
He says
least
it
to
doesn't
me,
look nice.
but-
Why does it not look nice to you?
No, not nice enough. Well,
I think it looks beautiful.
I'm just saying.
It's great. I think it's great. What are you upset with?
-7's the annoyance.
You want to put the 7 over here?
Is negative add over. We don't need to add it over because
We don't want to do that. No. We don't want to add it over. Sir, where do I upload questions? Use the link down there, dog. The link down there. Okay, so let's remember there was an identity for cosine of 2x, right? Did we write it down somewhere? Oh, you have it? Okay.
On my sheet, and I have the one I know it's.
All right, what is it?
Okay, which one do you want?
I want cosine of 2x going to something with sine squared. And I know there is one. There's one there. I know there is.
In terms of sine. 1 minus 2 sine squared x.
There we go. That's what I want. Okay, so 1 minus 2
sine squared x
is equal to the cosine of 2x, right?
Yes.
So we're going to use this
cosine 2x
right
in
here.
terms of 9.
So now this is going to be nice, Shari. Thank you. Appreciate that. I can see that. I can see that.
How do you write it? Write it up. You can write this up.
Yeah, you can just quadratic it. It's super nice. Yeah. Isn't this beautiful, Jeff?
Let's let something here. We'll do a let statement in a second. Let's combine all this and put them in order.
Yeah, okay, so 4 and minus 7 is going to be minus 3.
No, negative first. So negative 8 sine squared x.
Yeah, and then minus 8 sine squared x.
Okay, this is in normal order. Plus 10 sine x minus 3. Okay, and then here's a let. So let statement.
Yeah, so anytime you guys see something squared, something to the first power, and it not there, it's probably quadratic. Probably quadratic.
Okay.
That's right. Let
u equal. Let u equal. It's the other way. You're saying let the variable you want equal to something.
Okay, that's semantics, but yeah.
Variable you want equal inclusive. So for u squared is sine squared. Yep.
So negative 8 u squared plus 10
less 10
u
minus 3 in terms of u.
0.
Equals 0 in terms of u. In terms of u. Yeah.
All right, I'm gonna pull out the negative.
Can I? You wanna?
I liked that easier, right?
This is not a perfect. It's not a perfect.
Is it not? I think it is.
No, I'm saying that. No, I'm saying it. A perfect. What is a perfect? You know what a perfect means in my context?
Oh, where this is 1.
Nope. A squared plus b squared. A squared plus 2ab plus b squared. That's a perfect.
That's a perfect square trinomial, yeah.
This is not. I was checking and seeing if this was perfect before I took care of it.
Let me think. Multiplies to 24, right? Did we have that right? Yeah.
Statement.
Multiplies to 24, but adds to negative 10. Oh, it doesn't work.
Diff has this. It does.
Oh, it's 6 and 4. Oh, I'm so stupid. Yes. Minus 6 and minus 4. Thank you, Shari.
How does that work?
We have u minus 6.
How does that work?
U minus 4 is equal to 0.
Where's the 8
Oh,
going away?
no, I fucked up. I thought, whoa. Hold the phone. Ooh, I almost really messed up. Oh no, dude.
Yeah, you gotta be really careful. This is the neat button. You have to do something with it.
I almost really screwed up.
This to red flag.
Sorry, I gotta write this. Sir, take the comment.
Is it divided by 8?
Yeah. Okay, so I can pull a 2 out of here. Or 2.
Nope, not a 2. Nope. There you go. But I don't want to pull a 2u necessarily. Yeah, okay, you're good there in the case. I was checking, man. Sure, the other piece.
And then this is going to be a minus 1.
And 1 has to be something, so it has to be a 1. 4u plus 3, which is u minus 3. Yep.
Good.
So 2u minus 1 and 4u minus 3. Therefore, u.
Y'all quadratic formula enjoyers.
Yep. Okay, and let's do another let statement.
So that means the
Let-
sine of x.
Watch the order. No, let me give you another simple. This is what I've done sometimes.
Right?
Let is another let statement. We're going to flip it. So same let sine x equal u, which is the backward version of the first.
Sure.
So the u
Sine
is
of
what
x-
you're now including, and we're just flipping it back. Sine x equals 3/4. And
where
then
did
we
I have to
find
find this? On the interval of 0 to...
Let's first find her on the circle before we take care of the domain.
All right.
I don't know. I don't like 3/4. I'm not a fan of 3/4. I'm a fan
I
of
am.
1/2.
It's a 3... It's... Oh, if it was 3/5, I'd be happy. Oh.
3/4. I'm not a fan of.
Yeah, if it was 3/5, we'd be okay.
1/2 that I know.
Alright,
I know
so
the
sine
exact-
being 1/2, that happens
3/4
here
Not so
and
much.
here, right? No, here and here.
Sine function, by the way.
Yeah, okay. So
And
that
then
happens
dimension.
when this is pi over 6, right?
Pi-
And that's when this is 5 pi over 6.
Not pi over 6 there. Yeah, pi over 6. Yeah, which is right reference. Sorry. Yeah. Oh, Jeff. The arc sine of 3/5 isn't nice.
Well, it's a 3, 4, 5, and I know that one. That's 53,
Still not nice.
5337. You should know that one. You should know the 3, 4, 5s.
What about 3/4?
But 3/4 I don't know. Okay.
Well,
so
we know a way to find it. No, we know about it though.
we do know a
it's
way to
not-
find
we
it.
know it's
We gotta use a
yeah,
calculator.
it's
though,
arc
so
sine,
if-
but
yeah, we gotta use
that's,
arc sine.
that's probably
and
the
then,
only way this.
and then we gotta do 180 minus,
I
right?
don't know.
One sec.
No, not necessarily.
You know the arc
You'll
sine
find
is
the-
53 point. No, so arc sine
No.
of 3/5 is not 53. That's the arc cosine of 3/5. But
3/4. I wish 3/4 was nice, but it's not.
okay, well, one sec, sorry. Arc sine of 3/4.
Read the Twetson for me.
That says 48.6 degrees.
Read the Twetson for me before you do this.
Oh, you want me to put it in radians?
No, read it.
What's that? All solutions between 0 and 2 pi.
Read the Twetson.
Oh, round to two
Round
decimal
to
places.
what? Does it say?
Two decimal places.
There you go. I always do
Okay.
4. My teacher's always done 4. But read
Okay.
Twetson, so you don't round wrong.
Okay. Well, okay, let's do it in radians because I'm pretty sure we need it in radians. So
Yes,
that's gonna
you-
be 0.85, or and then pi minus that.
Yep. Minus answer T.
Yeah, so 2.29.
Those are nice at 4s and 3 decimals and 5 decimals, but they're
Mhm.
not like absurdly nice.
And then pi over
And then that's
6
not involved.
is a 2 decimal
We need
places.
an idea. We don't. Well, we need an idea because we still have to
There's 4 solutions
check
to
it.
this.
We still have to do all the cases.
Well, we're
There's
only going
inf-
once.
there's
We're only going
implementing
once.
this.
We're only going once around the circle.
So does it? So when we add a pi to it, is it not to go over? Or these? Or
Well, we would add a
say
2
under?
pi. We would add a 2 pi to it. The reason why on the other one it worked is because it was sine of 2x. So, in
These are the guys. Okay, and
yeah, in this question
but
we
you either have
we
to
had
do 1 or 2.
we had sine of 2x, and that causes you to have more than 2 hit within a
Try to-
rotation.
It's 0 and 2 pi, so negative solutions are not fun, are not counted.
No,
Okay, now write them as a list with an at equals, or write each individually with at equals. If you do them as a list, do them in order.
there you go. That's all of them. Yeah.
That's the state of statement. Because those are just numbers otherwise. And then one more. The next photo there. So, this red stuff.
Let me do Shari's. Because I want equity to maybe show up before I do his last one.
Sorry.
You put one in web screenshots, or actually, sorry.
Okay.
A couple.
Hmm.
Pickle Juice, what's up?
For a minute.
If Pickle Juice is around, I'll do Pickle Juice's question. Yeah, Equity says, "Yo, I'm here." Well, Equity, I just did both yours.
I think we can use Shari's. We're fine.
All right. If
Pickle
Pickle Juice shows up, I'll do this one.
Shari's already here, so Shari has priority at the moment.
Okay, Shari, you're here, so I'll do yours. Shari.
Technically, he's here, so he has priority. He would get priority because of timing, because we have to do by some time. So let me start with something simple. You want me to start with something like that already?
I'll do yours. Equity, stick around. I'll do your last one afterwards. I want to do this one.
I think I gotta. I already know something about this.
X
one.
to the 7th?
Not A. It's not A. I don't think it's A.
I don't think it's A either.
You know why? You know where my idea is coming from?
Because the limit as
I mean.
x goes to positive infinity and negative infinity is positive and negative infinity, so it has to cross at some point.
No. Here's the reason I know I'm doing off of it. If it's real solutions, we know there's 7 Tourette solutions. But of these, imaginaries come in pairs.
Good. I like that too. That's a very good point. Very good point there.
Doesn't even matter of imaginary, therefore there must
Yeah.
be an odd number of real ones.
Good. So it
Therefore,
can't
A
be
is
this.
automatically wrong.
Yeah, it can't be this. That's a good way to think about it.
That would be
Jeff was suggesting this way, which I also agree with, which is that the limit
yeah, trust me.
as x approaches infinity, well, it has to go to positive infinity here, and then it has to eventually go to negative infinity here. So it has to cross. It's also continuous because it's a polynomial. Okay.
Yeah, 7 must cross.
Well, I know by the rational root theorem, right? One of the solutions has to be 1, plus or minus 1, right? I don't think it's plus 1, so I think it's minus 1, right?
We can test them both though, and we can see which
Right.
one.
So, well, this is -1 minus 5, which is -6.
So it's not that. It's
Wait.
wrong.
Oh, is it? It's not
Isn't it?
-1
No, it's
then.
1. No, it's fine. 5. -1's fine. -3.
Is it?
Ooh, that's not. That's -3.
No,
I see.
wait, what?
I see a
-1
I see a
minus
-3.
5 is -1 minus 5 minus 3
Minus-
plus 1.
Yep.
Wait,
So
I
you're
thought the
wrong.
rational root theorem guarantees that the roots have to be
No.
some fucking
Read it.
the factors of the
Read the
top over
rational
the
root-
factors of the bottom.
Read it for me.
Well,
Look it up.
now I gotta go look it up.
Yeah. If you want, you're checking. Yeah. So we do this. Otherwise, it must be true.
The
They're
possible
mathematically
rational
wrong.
roots of a
It's not happening
polynomial
right.
function.
Possible.
Yes.
Then to stop you. Potential. Potential. What does potential mean?
Okay.
I know one thing potential doesn't mean. Guaranteed. Potential
Okay.
does not mean.
I
guaranteed.
thought it was guaranteed that one of them had to be that. I guess not.
Just going to read this. Just going to read what it is. Because it's
Because
potential, which is
we
not.
know there's guaranteed at least one real root, right? Even if all the other 6 were imaginary, I thought at least would have to show up.
There's 6 are because you can't have an imaginaries. And
Function is
Ooh.
always increasing.
and it's 1, 3, or 5. We know that much. Now we just start finding pairs of things. Now, are we allowed to, we're not allowed to Desmos, I bet.
No, I don't think they get Desmos
So
in
we have
India.
to.
Surprise,
We're not
motherfucker.
allowed drafting. Otherwise, it'd be a drafting calculator, but we're not allowed that because that'd be easy. That'd make this really.
Okay.
What can we do?
Yeah, so the derivative has all even powers, right? So if we take the derivative of this, we get 7x to the 6 plus 15x squared plus 3. This is positive, so that means it's always increasing. So that means it's only
Okay.
going to pass through once. If something is always increasing, it can only pass through the axis once. Wow. That's cool, Shari. That's pretty dope. I think that's dope.
Try Desmos. Give it to Desmos and see if it
That's really cool,
agrees
Shari.
with you.
I like that, Shari. That's a cool question. That's what we call like some like number theory type shit. Okay, here let's try graphing it.
That's just tactless.
So x to the 7th plus what was it? 5x to the 3rd?
5x cubed. 5x cubed. Yep. Plus something
3x
x,
plus 1.
Yep.
Yeah, look at that. Look at that.
Ooh,
Look at that.
yeah.
Yeah, she blows up.
If we add to the Twetson, we can add to the Twetson and see what it find all the zeros, which only one.
Wow. That's very cool. Very cool.
Okay.
Thanks for the question, Shari. That was really cool.
That was quick and simple. That was actually a lot simpler than I thought. A lot quicker than I thought.
Okay, I think equity is here, so I will do equities. Equity's here. Equity, you're here, right?
It's
First derivative test
It's
is the key to this problem. That's pretty cool.
No.
Because I don't see Pickle.
We have.
Where's Dr. Picklefield? Would be pretty bad. Speedster did ask an
I'm
interesting
saying
question.
equities. I'm skipping over the 1 hour. I'm skipping over what I feel like is not going to be not a good one, not an easy enough one to get through.
All right. It says a Ferris wheel
is 1 point.
Keep going. You're good.
It was it has
you
a
read
radius of 14 meters. A rider ride at the bottom of the wheel and completes 1 full revolution in 30 seconds. Therefore, determine a sinusoidal model for this Ferris wheel. How high is the rider after 5 seconds? When is the first minute of the rider the height of 12 meters off the ground?
Okay. Here, I'm gonna draw this out. Meanwhile, Shari's asking our chat, sir, do you know any trick to find out the root of any degree of quadratic function? I don't know. What's the trick?
He does.
Oh, he does.
He knows the trick. So, the root of any degree of a quadratic.
Is it Descartes' rule of signs? Could be.
I know the simplest rule. There's always the amount of roots of the degree. But that's. For a given equation, there must be as many roots as the degree says it must.
Okay, let me do this question. All right. So determine the sinusoidal model. So we know he enters at the bottom of the wheel. Okay, so he has to enter at the minimum here. Well, we can figure out the midline first, right? So the midline is like it's technically the average of the lowest and the highest point. So the lowest is equal to 1.5.
And the highest is 29.5.
You're right. It is.
4.5 plus plus 2 radiuses.
You're right. So
write that as a 4, not a. Write that as a clear 4.
So
it's
the
not
middle.
It's
a 9, right? It's a 9. Yeah. Okay. So
Yep.
So 29.5 plus 1.5 is 31, so 15 is equal to 15.5.
Yep.
Okay. That's the midline. And then I need it to start. I need it to start at the lowest.
Middle and then
so this is weird.
Here's another thing too. For this case, the easiest way to find the middle is do the lowest plus the radius, as it is.
Correct. You could have also done this plus this. Yeah, totally.
Perfect.
So if I need this to start at the lowest point, then what I need to do is I need to shift it over this way.
Why you're shifting it then?
Why am I shifting it, he says? Because I need when t equals 0 for it to be at the lowest point. Okay. So I need to shift it by pi over 2. Alright, shift by pi over 2. Okay. And then for the period, the period is 30.
Seconds it does around once.
So it's always like sine 2 pi over the period times t. That's like sine omega t, right?
Well, the period is 30 seconds. So 1/15 pi t, but I don't know what t is necessarily.
Wait, 1/15. Oh, because 2 pi over 30, yeah. Okay.
And doing
So, and then the amplitude is equal to 14. So you get y is equal to 14 sine, and then we're going to say 2 pi, or so 2 pi over 30. So that's going to be pi over 15.
1/15 over 10.
Right,
T,
good.
but I don't know
And
what T is
then
yet.
and then we need to shift it by pi over 2.
And it's within the sign, and we're shifting within the sign, not outside the sign.
What do you mean inside the sign? Oh, yeah, within
Yep.
the sign. Yeah, good.
That's
And then we have to raise it by 15.5. I think that's
which takes care of the
correct.
middle point.
Right.
Okay, here's a good way to prove that. Let's find the minimum of that. Let's make sure the minimum of that is what we want it to be, or graph it, of course.
Well, the minimum is when t equals 0, because then we have sine of negative pi over 2. Sine of negative pi over 2 is 0. All right.
Is that times 14 plus 15.5 what it should be? Yep. So we get, and then if we and want the highest point to be 29.5.
Wait, no, sorry. Sine of negative pi over 2 is negative 1, and negative 14 plus 15.5 is 1.5.
That's lowest, good. And then we want the highest point to be.
You're right. We could have done cosine. Usually when they say sinusoidal model, though, I think they usually want sine. But negative cosine would have worked, too.
And then we also need to make sure that the highest point is not 29.5 as well.
Well, that's okay, because whenever this whole thing is
Or the
1.
model is not accurate.
Yeah. Okay.
And
What's
also,
up,
I will
1K?
say,
How's your knee doing?
there's a-
Not as dislocated, I hope. He said he went crazy on a cricket match and he dislocated his knee. This is stable with the rotation. What's
You're
wrong?
saying y equals graph on the top. You're saying this is a notation thing. You're
Okay.
saying y equals on the top, and the bottom you're saying a function of y of t.
Oh, you're right. I should say y of t. You're right. I should. I'll fix that.
You're seeing a function on the bottom, and you're seeing a
Yeah.
statement on the t, or something of that nature.
Y of t. Okay. Oh, very cool.
8.5?
This is pretty cool. This comes out to be a nice number. That's actually really dope. Oh, that's actually really cool.
Supposedly it is, yeah.
How's
Why
it
you
doing
approximate it
that?
then?
How's it doing that, by the way? Oh, because pi over 3
As
minus
in
pi
what?
over 2 is pi over 6. Sine of pi over 6
Which
is
is
1
nice.
half. It's really cool.
There's y. So is it an approximation or is it an equals?
Oh, you're okay, YX. You're fine, dude.
You're saying
No,
an
it-
approximation.
oh,
there,
yeah, it's
which
not
is
approximation. It's actually equal to, yeah.
What is
Okay,
it
and then
equal to, though? What is it equal to?
It's equal to 8.5. 8.5 meters? You want units?
8.5 what?
Meters.
Yes.
Okay, and then it says,
and then parts.
when in the first minute are they at a height of 12 above the ground? Okay. So they're saying
Oh, I see.
0t less than 60 is
No,
y
what
of
do they
t
say?
is equal
You
to
recognize what they did with that?
12. What's up?
You recognize what they did with that statement? When the first 2 pi revolution,
Oh, is it?
they did that to say it as 2 pi. They sneakily did that. 2 revolutions, which is 2 pi.
Mm. Yes. Well, no. 60 is 4 pi. Yeah, within the first 2 revolutions,
Yeah.
right? You're right. Yeah. Sorry. You're right.
When
yeah,
the first minute, yeah, every revolution is 2 pi. Yeah.
Uh huh.
Neat. And if we want win, then we want at what time t? Yeah.
Okay, so let's try to solve for this. This is actually really interesting. So 12 equals
Where's
14,
the 12 coming from? Yeah.
Because I want to know when. I don't know when the height is 12.
Yeah. Phi of t equals that. Yeah. 12 equals that. Yep. Yeah.
Plus 15 point. This is kind of a messy
Okay.
question, honestly. So we got to subtract, right?
Add.
So I get negative 3.5 over 14.
Yep. We can make this better. We can make this a lot better. We can make that fraction a lot nicer. You know
Oh,
why?
wait, you want to make that is
Let me
that
do a
is that
movement for ya.
1/4? Is that 1/4?
You mean no? Let me check. Let me do it. Multiply both top and bottom by 10.
35
So
over
it-
140?
Multiply 35 over 140.
Well,
divide
wait,
both-
one sec.
both top and
I
bottom
think
by
3.5 times 4 is equal to 14. Right? Because 3 times 4 is 12. And then half of 4 is 2.
In pieces.
Yeah,
It
so
was
this is
easier in
neg-
pieces.
negative.
That was me.
Yeah. I get it. I get what you're doing.
1470 sort of. Yeah.
Okay, cool.
Now fourth is annoying. Like fourth is annoying.
Yeah, it's not a nice one, is it?
Fourth. Nope. Let's find the art side of this.
Okay. I'm gonna say that.
Wait. You do a tret? Let me do a tap. Yeah. Before you, let's just do this in one calculator push. Don't do the bots. We don't need a bot. We can't use a graph for this.
The box. Well, sine is
We can't
negative
use a graph
1/4.
for that. We don't know negative 1/4 on a
No, but I
interval.
want to show where that is though, because negative 1/4 means it's down here.
At some
Right.
point.
But watch where the next one that this happens. The next one that happens is over here, Seth. This is why it gets weird, because this is the other one that happens.
Oh no.
Right? Do you see how that's that's weird? Because this one is like equal to this one, and then it's like, oh man, how does that work?
180 plus something in the negative version of whatever that thing. You know.
Yeah, do you see how it's weird? Sorry. So you have this angle. Oh,
By
yeah.
the
Let
way,
me.
that's
let me-
not a true.
Let
That's
me
not
get it.
negative 1/4 though,
Why not?
because that's negative 1/4 in the y direction. We don't want that. We want negative 1/4 as a statement
Yeah,
of
but
sign.
Yeah, but I mean, this is assuming that I have a hypotenuse of 1. Opposite of hypotenuse, right?
No, I'm saying that's not negative 1/4. That's one. That's some number at over negative 1/4. Is what it.
Oh.
Yeah. Negative 1.
Yeah, correct. You get this?
Y bar. Y bar.
This is my angle bar.
Yep.
Why don't you do inverse sine? I will, Equity. What I want to show you, though, is that when you do inverse sine, you're only going to get this angle, and then technically you need to do 180 plus that angle to get the full second angle you need. So we can do it. All right, I'll get you an angle for it. Give me a second.
Can I? Before we get the angles, let's do when we do a simple movement that actually might be nice here. Write
What's
this
a
out
simple movement?
for me. We can write. We can do this in one calculator push. Really, in 2 sets of calculator pushes, so we don't have to deal with approximations.
You
That's
can't
hard.
add pi. Wait, no. Yeah, use the reference angle and add pi.
Yeah.
Okay, what do you want to do here, Seth? You want me to like rewrite this as some shit or something, or what?
I'm gonna rewrite it. Yep, in terms of t. So arc sine of both sides for me.
Okay.
Arc sine of both sides. It's all through. Okay, Taces time. No, this is Taces. Because we have to do this in Taces. Yuck. Tace A, where we're doing where we're just doing the negative 1/4 as it is set.
Mm-hmm. And then the next one I think is 180 minus, or so it's pi minus arc sine of negative 1/4. Okay. And there's an additional problem here because then this needs to be like 2 pi n plus or minus this whole thing. So I don't want to expand this yet, Seth. I just don't want to do it. Let me just not expand it yet. Okay. We're going to keep it. I think there's an easy way to do this in terms of renormalizing. Okay. So I'm going to say let t equal pi over 15 or okay. Yeah, let t equal 15 over pi u. Let me just do this, okay? So now our bounds is going to go between 0 and t and 4 pi. Because if 60 equals 15 over pi u, then times by pi divided by 15, now u goes between 0 and 4 pi. I'm gonna reschedule that just because it'll make things nicer. Trust me. Because watch what I have now. Now I have negative 1/4 is equal to the sine, and now this is going to be pi over 15 times 15 over pi u. And then this is minus still pi over 2. So this cancels. So now we have negative 1/4 is equal to the sine of u minus pi over 2. Now this is a lot nicer. And then eventually we'll come back, and because they probably want it in seconds, and we'll get it within seconds. So, you're gonna have on my website, some of them teach, yeah. A lot of them are just kind of like board members of my nonprofit. That's how it works. Negative 0.253. So negative 0.253 is equal to u minus pi over 2. That's one of the solutions. And then the other solution is the positive of this angle. So making this positive and then adding pi to it. So the other one is pi plus 0.253 is equal to u minus pi over 2. And then this is also plus or minus 2 pi. And then this is also plus or minus 2 pi n. Hey, I'm about to go into high school. What does sin do so I can be ready? You must repent. No, but in all reality, sine is just this. It's just an oscillating graph. It just goes back and forth, and it has some cool properties. But it mainly we use it in the real world to describe things that go back and forth, like waves or sound. In math, you learn about how to do things with triangles using sine and cosine. Nice. What's up, Obi? Big raid from Obi today. Thanks, bro, dude. Shout out to Obi. Obi's great. Okay, so this gets me u is equal to what is that? Pi over 2. Sorry, plus that thing. So 1.32 plus or minus 2 pi n. And this gets me u is equal to 3 pi over 2 plus 0.253 plus 2 pi over n. 2 pi n. Did some differential equations, some factoring by grouping, and some math for space exploration. Have you ever heard of like the, was it Kerbal space program? That's one I hear about a lot. Okay, so remember, we need some solutions between 0. Yeah, that's a fun one, yeah. I had a friend that was like super obsessed with it. He wanted to like get hired by SpaceX for it. Didn't work out. Ended up driving for Uber. I don't know what he's doing now. I hope he's doing something good. Okay. Equity, are you following along with what we're doing here? Okay. Like, you understand I just remapped t to this u thing? Because going between 0 and 60 seconds is the same thing between going 0 and 4 pi. It just looks nicer. Because now I can see here, right? If I subtract 2 pi from this, that's going to drop me. So I can't do that. Okay. So my solutions are 1.32. And then I can definitely add at least one of these 2 pi's. Right? So then it's going to be 1.32 plus 2 pi. But then I can't add 4 pi. Right? Because that would put me over the 4 pi. So that's my two solutions. So 1.32. And then this plus 2 pi. So 7.6. Okay. This one's a little bit trickier. But obviously I can't subtract 2 pi.
That just looks for you, though.
We will solve for you eventually. I can't subtract 2 pi because that'll drop me.
We already have you, though. We already solved for you.
Yeah, I know. I just need to convert it. FedEx says, how do I ratio partition when you're done? I had a question on my geometry EOC, end of class, I guess. Ratio, how do I ratio, what's ratio partition? Do you have a screenshot of like what that means? I mean, I could look at it later, but maybe Seth, can you look up what like a ratio partition is? Ratio partition.
Yeah.
Someone's asking in the chat. Oh, okay.
Fractions, isn't it?
Is that just like inscribed triangles?
Ratio partition means fraction, but
what grade of geometry are you in? Like 8th grade?
good, it says fractions.
Okay. So wait, this one will be 4.96 or 4.97. And then I think I'm allowed to add 2 pi.
No.
But I'm definitely not allowed to add 4 pi.
You're allowed to subtract, though. Aren't you? No, you're not. You probably have
No, I'm only allowed to add 2 pi. Yeah, someone says like breaking things into a certain ratio. Yeah, I feel like it's just like inscribed triangles. Okay. So these are your answers, okay? But then we need to convert them to time. So if t equals 15 pi over u, wait, 15 over pi.
Try your other one.
Then now what my t values are going to be. So it's going to be 15
pi. Multiply, yeah.
I'm just going to multiply by that, right? Here, let's just store that as x. So I'm going to say 1.32 times x. So here's what we got. We got 6.3 seconds. 23.7. 36.3. And then ooh. Do you see how it's almost exactly 60? Uh-oh. Sorry, I got to get the rounding on this.
Went over.
No. I wrote down the wrong one. I wrote down the wrong one. This is 11.25. I fucked up. I was like, yo, that's too exact. Oh, thanks for the follow, Sponge Dinosaurs.
That's over. That other one is over.
Yeah,
So.
well, that's what 4 pi is. Sorry. Yeah, duh. I was like, oh, damn. Okay, 53.7 seconds.
Okay. And also
Nice.
it made sense to not be subtracting. It actually made sense to not subtract in that case. You know why?
Because it's negative time.
So.
Okay,
Oh,
let
we have
me...
Chantrix to do.
Yeah, I do have Chantrix. Chantrix has been waiting a lot. YX has an interesting question.
Didn't
I'll
look
check.
nice.
Let me...
I can also show you. I can also show you something interesting in trade if you want me to. Yeah.
You're very welcome, Equity. Good luck, dude. One sec. The line segment bisector, but not the midpoint. I don't... FedEx, do you have an example question? It's sometimes hard to write math things in words, but if you can show me like a screenshot of like a question similar to what you're talking about, I can figure out pretty quickly what to teach you. Okay, sorry. Let's do Chantrix's, and then I see yours YX. Yours is
Oh, it's interesting. Okay.
this is
You want me to show
YX's. We'll do
me to
this
show you
one
before?
afterwards. Chantrix's is interesting.
No, the rates of partition. I have it.
Oh, okay. What's the rates
Partition
of
a line segment AB. Partition a line segment AB into a ratio AB, A divided by B, involves dividing the line segment into A plus B equal parts and finding a point that is A equal parts from segment A and B equal parts from B.
What?
The image is easier to understand for me.
Sorry, what was the name? What did you Google? What's it called?
Ratio partition.
Oh.
Nice.
See?
That's super weird. Huh?
You find the ratio notation.
Yeah, you can just ask questions. Totally. Here, if you want to submit a screenshot, Spirit Dome, just submit a screenshot there. We'll do it.
Oh, we're doing that's Taylor's branches, by the way. We won't have time for that. We only have 10 minutes.
Yeah, we'll see.
We might even have time for the Chantrix's one.
I want to do Chantrix's. Okay, but sorry, this was point ratios. What FedEx was talking about. So, I see. So the ratio of the distances is just a ratio. What's special about this? AP over PB is equal to AX over BX, which is equal to A over B. But like what does this have to do with the slope? Yeah, and then the percent of the whole, sure. Like A is the A divided by A plus B percentage of it. But what does this have to do with Y over X? Bro, dude, I love this. Dude, this is my absolute favorite. My favorite thing they put on these types of websites. I think we have it in our Discord as like a thing. Yes, dude. There she is. Whoever this girl is, I need to know, dude. I forgot. It's just too funny. Someone finally said FedEx correctly. Cool. But yeah, I'm not sure exactly like what's this used for. Maybe it's used for like dilation or stuff. I mean, I know it for. Oh, you know what it's used for? It's used for also for this is cool. This is where it's really useful, ThedX. How do you send a screenshot in this chat? So you can't dump screenshots in Twitch because Twitch won't let you do that. But if you go to this website that I linked, here you can put your username. You can select a file to upload, and then once you do it, hit upload. And then it'll send it to our Discord, and then we'll go through it. That's how it works. Okay, but how this works, ThedX, by the way, is if you're looking at like these are inscribed triangles. So this is actually pretty cool. And then this is like the big one. Okay. So the ratio of the sides have to be equal. So 2 over x has to also be equal.
6 over x plus 7.
Has also to be equal to 2 plus 4 over x plus 7. The other way to write this, right, is if you cross them, right, this is 2 over 2 plus 4 is equal to x over x plus 7. See how it's this divided by the whole is equal to this divided by the whole? Oh, where's the link? Oh, it's just here. Submit. The submit.actual.education. Hey, first time here. I love what you're doing. Thanks, man. Good luck on your DiffyQ exam Friday. DiffyQ is a fun class. I like DiffyQ. Very relatable. Let's see. Shantrix gave a good question. Let's do his while we have time. In the diagram, a central circle contains the number 36. Positive integers are to be written in the 8 empty circles, 1 number in each circle, so that the product of 3 integers along any straight line is 2592. If the 9 integers in the circles must all be different, what is the largest possible sum of these 9 integers? Ooh. Okay. Well, I can do 2592 divided by 36, right? Because I know this has to be, it has to be this times this times this, right? Right, dog?
Mm-hmm.
Which I think that's also 6. Oh, it's 72. Okay. Okay. So that tells me, for instance, that like 8 times 9 would be correct. Right? Oh, okay. Well, let's just write out what all the factors of 72 are, right?
Nice.
So you have 1, 72, 2, 36.
They're all different. Yep.
3, 24, 4, 18, 18, 5, 5 doesn't work. 6 and 12, 7, 6. Yeah, there's Master Chief. No, I fucked up. Sorry. 7 times 7 doesn't work. 8, 8, and 9. Right? And then we're done, yeah?
And backwards. Yep.
Okay. So Jeff says, I think you want the largest factors since there's some with the other factors will be the largest. Uh-huh.
Reason 8 and 12 numbers.
Well, I mean, for instance, like this
9 and
adds up to
12
17. This adds up to 18. This adds up to 22. This adds up to 27. This adds up to 38. This adds up to 73. Right? This is why... yeah. Twitch is cool. I agree. You can trigger things. Yeah. Okay. So, we want the 8 numbers. Yeah, what's up?
Yeah, listen.
Don't I just want these? I think I just want these.
No, that's wrong. You know why?
No.
What is the rule?
Why?
The 9 integers in circles must all be different. But 36 is not unique. 2 times 36 is not unique.
Oh,
This is already a
fuck.
36.
No. Oh, we can't have the
Therefore,
36.
that one can't be usable. That's an
No.
illegal answer choice. You can't use that one.
Surprise, motherfucker.
He's 2
We
times
can't use that one.
36.
Damn. We got done dirty.
He's already used.
Okay, so then it's this one and this one.
I have to trick people.
Join the VC. I mean, you can join the VC. As long as you're like chill and don't start like yelling out Kanye lyrics and stuff on Twitch, you're fine.
So,
like-
what's an at?
But we are live, so please don't get me banned.
What's an at B on that?
Okay, so let's do this. So this is 73 plus 3, 76. 76 plus 24 is 100. 104.
What are you doing? What are you doing
122. 128.
You're doing the
What?
hard way, you know that? 73 plus 27 plus 22 plus 18. You already added them up. You already grouped them, added them.
Oh, I'm retarded.
1 plus
Okay.
72 is 73. Just add the big numbers up. And add
Oh, and then
36.
wait, and then plus 36.
73
You're
plus
right.
27 is a multiple of 10. 22 plus
40
18 is a multiple of 10. Therefore, it must
This is
be
100,
any
140,
different.
176. Wow, we got more bits. Or a follower goal. Oh, we hit our follower goal. Wow, look at that. 1,600 followers on Twitch. Big.
That's dope.
Okay. Indian Society 176. I agree, it's 176. Cool.
So do you
Nice.
want to play with
Good job, Shantrix. 1,600. Yeah, what's up, Zach? We hit 1,600.
I'm just putting an integral.
40 squared followers. Yeah, big shout out to Zach.
There's an
Zach
integral in the, there's an integral in the Discord.
There's an integral in the Discord. Okay, one sec. Sorry,
Yeah,
that's not
it's-
the right
that's-
thing. That's the right thing.
Find
Is this
the
Spirit
integrals
Dome?
From 1 to 27 of them.
What's up, Spirit? You want to
natural
come?
log
You want to
of
come?
expression
Spirit, you want to come
times
talk in the
two
VC
that
about your
square.
question, dude?
Yeah,
What's-
it's
What's up, dog?
It's just an individual.
Okay. This one looks interesting. Wow, ln of x cubed. Wait, square root of x squared? Isn't that just x?
Yeah.
Yeah, I got no clue, bro.
Okay.
E.
Well, I'm pretty sure this
I
is just
think
x.
by parts.
Not Ready. No, it's not. T root of x squared is not just x.
The square root of x squared is
No,
not
it's
x.
the absolute value of x.
Well, sure, but
Not
ln
the-
can't
yeah,
be
that-
negative anyways. ln can't be negative.
Cube root of x squared is x to the 2/3 power.
Oh, sorry, it's the
So you're
cube.
saying
Okay.
that
Oh,
two-thirds-
whoa. I'm sorry. I'm going full acoustic here. Sorry.
A read.
I thought this was this cubed. No, this is the cubed root of this. Dude, fuck your teacher. What?
Oh,
It's the cubed root of x squared.
There it is.
It's not right.
It's more nasty.
So it's x
I
times
see, I
x.
see, okay.
Do you see, bro? Yeah, your teacher. That's mean, dude.
yeah,
What?
3/2, right?
Home dog, like put this like right next to here. Wow.
Yeah,
Wait, we
that's
hit
how
our
I write
follower
it.
goal again. Why do we just keep hitting our follower goal? Thanks.
Be more careful.
Okay, so now this is 1 to 27. Ln of x to the 5/3, right? Dx.
Yep.
And then
Is it absolute value or is it parentheses?
well, I'm
Spirit
just
Dome
gonna pull.
said- said it's not.
It's absolute
no,
value.
It's not. The 3.
No, because now this
If
is
it's
odd.
the cubic root, it's probably not that.
Yeah. So this is gonna come out. So now this is 1 to 27, 5/3 ln of x dx. This is a bad integral. Integral of ln of x ln of x.
Would it help if I did?
What's up, AMA? You want to come say something?
Let me see if I have a formula here. Let me see if integral formula is.
Oh, it's
what I
x
think
ln
it
of x
is.
minus x. Oh, okay.
Get out of my. Yep.
Yo, hi. ln of x and dx on its own, it's just integration by parts, you know?
Integral of lateral.
Zach says yes.
Oh, yeah,
AMA
they-
says integration by parts. Cool. Let me see why that is first off.
Why do we
Integr
the parts if we just have a formula?
Well, no, but let's show them. Maybe they don't have the formula, you know? So I'm going to say that u is equal to ln of x. What? And then du is equal to 1 over x dx.
That's
And then dv
What
is
grade-
equal to dx. So then
Before
v is equal to
before you
x. What's up, Seth? What are you asking, dude?
before you do that, does Spirit even know what calculus 2 is? What integration by parts even is?
Yeah, I mean, that's
oh,
a basic
I'm in
thing.
calculus too. I get
Yeah,
an exam
bro.
on
You
Friday.
need to know integration by parts if you're doing this shit for sure, dude.
was 1. I was making sure. I'm only meant to calculus 1. Sorry.
You're okay.
I was making sure.
So this is equal to x ln of x, because that's uv, and then it's minus the integral of v. So that's x du 1 over x dx. Oh, look at that. Cancel, cancel. Okay, so
Yeah,
that's
exactly.
x ln of x minus x. Oh, that's very cool. It is integration by parts.
That's dope.
That's super fucking dope. All right,
I
nice,
was
cool.
making sure that first in calculus 2.
You use the product
Maybe.
rule. Oh, that's interesting. Someone says use the product rule. I think you can just do this. So this is 5/3, and then it's x ln of x minus x from 1 to
From
27.
The entire thing, yeah.
So then that's
well.
5/3. Let's see if this simplifies. So this is 27.
It does.
27 ln of 27 minus 27.
Minus. Keep going.
And then minus 1.
Minus-
Ln of 1 is just
Yeah,
0,
one.
right? 0.
Yeah.
Yeah.
Minus 1.
And then minus minus is plus 1. Okay.
Yep.
Cool, dog.
Plus 1.
So,
So-
what?
That's what 27. I don't know that.
So 5/3 of 27 is 45. So 45 ln of 27 minus 26 times 5/3.
No.
Yeah. Right.
There you go.
Minus 27 plus 1?
Yep.
And then this isn't anything.
You can do
nice.
this easier.
Whatever.
It
I'm just
is.
gonna,
It
this is your answer. This is good enough.
5/3 of 27 is 45. 5/3 of 1 is 5/3.
Sorry, what?
And then do the after this. 5/3 do just
You're welcome,
review.
Spirit, dude.
5/3 is negative 45 minus 5/3. Negative 46 and 2/3.
Oh, okay. Negative 46 and 2/3. Okay, sure.
What is the natural out of 27? Just to see if it's anything nice. If it's not,
It
we
is.
don't, we
It's
don't worry
not.
about
No,
it.
because this is e to the what equals 27. That's nothing. Yeah, it doesn't work out. NASA says, hello, this is what I'm looking for. Well, I'm glad you found it, dude. Yeah, we're Actual Education. We're a non-profit that helps kids out with math and science and tutoring and fun shit. And we play games. And yeah,
Problem where we're not going to get to, and then we have.
do we have any other screenshots that came in? AMAs? Let me do AMAs because
you have the ones that we
I'm gonna do AMAs because
said there were 3 problems.
well, it's okay, but AMAs like woke up at like God knows what hour in fucking Egypt, so like I'll
Yeah,
help them.
it's- And this is going to be trigonometric identities, but it's going to be with
Okay.
imaginaries, which means you need a trigonometric identity.
Oh, dude,
I
this
don't
this should be Zach's
I have
favorite.
I have the answer. So like when you finish it, like,
Okay, I'll
send
finish
over
it.
the answer.
All right, let's see if we can get it first. Cosine of 3 theta. What?
Did a trigonometric identity sheet. You don't need it. And then for imaginaries. Is this the... No, it's not. This simplifies. Yeah, this is trigonometric identities, is what I'm saying. Grab a trigonometric identity sheet.
Well, one sec. Is
So we
this?
can go do 2 sine 4x.
I want to know if I can just do this in the complex plane or something, because isn't like x equal to r cosine theta, and then y is equal to r sine theta, but then this is times I, right? Is it?
Don't know anything.
No, but this is minus and plus. I wanted to express this as like r
I know one
times e to the something theta. Zach,
I
come
only
on,
see
dude. This is Zachland, isn't this? This is a Zachland question.
Jeff says you can.
Okay, let's see it. One sec.
Jeff is trying to refute what you said that it can't be.
He says I can't or I can't.
You can.
Okay, this is what I want. I want this.
Yeah, Jeff
Euler's
says you can do it.
formula. We're gonna use Euler's formula. Can I use Euler's formula? AMA, is that okay?
I'll send you. Yeah, sure. Yeah, but I also send you something. Okay.
Okay, send me something. Oh yeah, Spirit Dome, you're totally correct. Yeah, I could have written 27 as 3 to the third. Yeah, and then you could pull the 3 out. That is simpler. You're right.
For all values, let me read this. For all values of n in complex plane z, i.e. n is an integer number, then we have cosine of theta plus I sine of theta to the n is cosine of n theta plus I sine n theta.
Yeah, I mean that comes from this, right? So if there's an n here and then an n in here, then this is the same thing as this to the n, which is the same thing as the whole thing to the n.
What this means is this is a Topicat formula. This isn't a Topicat our problem. Is that what's our problem?
Yeah.
The right side our problem. Pieces.
I just remember it was something
That
like this, but
top part, what's like
top part's easy.
cosine of-
Easy. This is e
So
to the 4i theta,
X.
right? For this.
or
And then
x,
this is
yeah.
squared. And then
is
this
Is it squared or is it the eighth power? Does it
well,
says-
it will be to the 8th. So that will be e to the 8i theta.
Is it though? You're squaring. You're multiplying powers together. You're doing a power tower.
Yeah, a power to a power means we multiply the powers.
No.
Yes.
What's 2 squared equal to?
2 squares
What's-
equal to 4.
5 squared equal to. That's not
5 squared-
multiplication of power.
That's equal to 25.
That's a power tower.
Sorry, what? I think I know what you're talking about. You're saying if I do like 2 to the 2 to the 3,
I mean,
this is technically 2 to the 8th,
Yeah.
right? Not 2 to the 6th. But when I do this,
That's what it-
I'm
that's
squaring the
saying.
whole thing. So I just multiply by the exponent.
Okay.
Do you get that, Seth? I'm not raising just the exponent. I'm raising the whole thing. So I'm allowed to multiply the exponents.
Okay.
That's a valid
That's what I
question.
want.
That's a
Just-
valid question. That's valid. It's valid.
And then
This is weird though, because the minus, well, the minus sign means instead of going up, I'm going down. So I have to do like, I think I have to do 2 pi minus that angle.
isn't it plus a negative? It's just a negative by. Uh-oh.
No. Cause watch.
Minus.
So this for
What's
instance is like, this is like theta, right? This is like positive I sine theta.
Jeff has another. Cosine of 2 theta is the same as cosine of negative 2 theta.
I agree with that. That's fine, but my cosines aren't negative. The issue is that my sines are negative.
Which signs are not are friendly, right?
Oh,
Are
I
some
see what he's
friendly or
saying.
unfriendly?
I see what he's saying. He's saying
They have 2
I can
theta.
write the cosine of 2 theta as the same thing as the cosine of negative 2 theta, and then I can write the negative sine of 2 theta as sine of negative 2 theta.
That's addition. Well, that helps.
So watch
That's
this.
addition,
So
bro.
this is now cosine of negative 2 theta, and then this is plus I sine of negative 2 theta. Because it's
While
even
we are on
odd.
this, before we do before we do the pieces, let's do the other one the same way.
One sec, let me read chat. I got a couple people in chat. One sec.
Yep.
Sir, do you know about titration and maths? I do know about titrations. I do a lot of chem. Denny said, Dennis, hey, Dr. Gold, figure I'd just pop in and say hi. I might plan on switching my major from astrophysics to computational mathematics. That's cool. Both valid things. I did not like astronomy when I was an undergrad. I had a really bad teacher for it, and it kind of like shooed me away from it. But whatever works for you, dude. Computational mathematics is also very important. Good. So he says, isn't e to the minus ix equal to cosine of x minus I sine x? I agree. And that's what we wrote here. Yeah. So this right here is going to be e to the negative 2I theta to the 6th. So that's going to be e to the negative 12I theta.
Yep. We can.
And then this
multiply
one
that.
right here.
Or we do that, we can multiply. 8I theta plus minus 12I theta is negative 4I theta.
And then so then this is e to the
The top is
negative 3I
Negative-
theta. Oh, yeah, we'll get that. We'll get that. Cubed, which is equal to e to the negative 9I theta. Okay, cool. So
Yep.
then, yes. So then let's multiply this times this. That's this.
No. Now it's
Right.
we don't have to do that anymore. Now we just add and subtract.
Yeah, we just
8I
add them. Yeah,
theta.
yeah. E to the
No.
8I theta times e to the negative 12 I theta is the same thing as e to the negative 4 I theta, right? And then we divide this by e to the negative 9 I theta. So divided by e to the negative 9 I theta. So then that gets me e to the 5 I theta. And e to the 5 I theta is the same thing as cosine 5 theta plus I sine of 5 theta. I believe that's correct. Is that correct? That's correct?
Yeah.
Hell fucking yeah, dude.
Yeah, you did it like in a way I didn't even imagine that you could solve like the equation like that, and I even know like that was a solution, you know.
Oh, that's cool. It's a very cool time where like Euler's formula comes in handy.
Like the answer, yeah.
All right, let me check it.
Ooh,
Let's see the answer.
more natural log work. Ugh. Okay.
Spirit Dome, you breaking my spirit, dude.
Integral.
1 sec.
This one was gross.
I think he was setting the oh, very cool. This was 1 sec. Let's see. This was the solution to it. Oh, interesting. They never put it into e to the I pi theta form, but that works as well.
There's no need to.
You didn't need to, but I like putting it into the e to the I theta form. I think that's a very useful form to have it.
We have another integral.
Good job, Victor. That is correct. Dennis says, I really like astrophysics, astronomy, and all that jazz, but my professors for physics 2 and 3 have been huge thumbs down. Uh-oh. Yeah, that is the problem, and I'm seeing that even now. So I teach physics at UCLA. I teach like early mechanics for students, and the unfortunate thing is that physics professors, especially if they're getting hired to like good universities and whatnot, they're not getting hired for their teaching. They're getting hired because they can do really cool research, really groundbreaking stuff. Unfortunately, a trend here is that the better you are at doing like novel, groundbreaking research, the worse you are at explaining basic concepts. So I understand that undergrads tend to have a rough fucking time with the physics professors. And this is why I tell people, if you're taking intro physics classes, go take it at a community college. Go take it somewhere where the person teaching you does not have to do research. They don't have to write grants, and all they have to do is teach, because they're going to care a lot more about you like actually learning. Yeah.
I took physics in like my first semester.
Yeah.
I'm in computer science. Yeah.
Yes.
So, I took physics. I had like no idea about physics. Like all I ever took was like some like speed time graphs, resistance, like stuff like
circuits.
that. And then I go in. Yeah, exactly. Like just very basic stuff. I go in. Like they teach thermodynamics, electromagnetic.
Uh-huh.
I don't know.
You're just like, uh-oh.
It was really hard. Yeah.
Yeah.
And my professor, he didn't teach. He was just like, this is the topic. This is how to.
He's like, yo, fuck around, find out.
This is like the equation. Yeah, exactly.
That's so unfortunate.
I had to teach myself.
Yeah.
Myself.
I've heard that a lot. I've heard a lot of students be like, they have to teach themselves. Luckily, there are a gazillion cool resources out there for you guys these days, such as YouTube, Khan Academy, whatever that, like organic chemistry professor guy or something.
Yeah, it's really good.
We have our streams here. Like, that's what AMA is taking advantage of now, and like anyone else in the chat. Like, you can just there's so many other ways to get help. You have a quiz? You have a quiz coming up?
Yeah, on Saturday.
Wait, you go to school on Saturday? What? That's rude.
Yeah, in Middle Eastern like countries in general.
Yes.
You have like the national holiday. Like for you, Saturday is always holiday, right?
Yeah, Saturday's always a holiday because like Sunday is supposed to be the holy day.
Yeah.
Right, yeah.
Yeah, exactly. So our holy day is Friday.
Oh, okay.
So yeah, exactly. So like our Friday is your Thursday,
Okay. So, but wait, do you get Sunday?
I mean,
wait. Do you get Sunday off?
Yeah, exactly. Do
you get Sunday off, or do you have to work on Sunday?
No, I have to work on Sunday.
So wait, you only get one day off though.
Friday are off.
Oh, Saturday and Friday are off.
Yeah,
okay.
but like Yeah, Saturday and Friday. But in university, you have to take Saturday sometimes, you know?
Oh, what? Dude, that's so mean. You have 6 days of classes, basically?
Yeah. Yeah, exactly.
Jesus. Okay. Well, that's rough. I thought it was bad me having to teach Monday through Friday, bro. You also got to go in on Saturday. No. Oh,
Yeah,
dear.
exactly.
Okay, let's try to do this question from Spirit Dome. It looks like an integral with ln and some other bullshit going on.
And also it looks like a quotient rule with iteration. Yuck.
Well, there is no quotient rule
Yeah.
for integrals.
No, I'm saying it's quotient rule with iteration, so it's the whatever it would be. But I'm saying it's this yuck.
I think this is integration by parts, Spirit, is it?
Yeah, it is.
It is.
And
We
it's
agree.
also indefinite, which means you have to have the plus C on the end of it.
Okay. Yeah,
It's
whatever.
in your solution too.
Dude, fuck that plus C, dude. People who think they're all like, "Oh, you didn't put plus C on there." I'm like, get the fuck out of here, dude. I don't care. Okay, so I think this one is integration by parts. So we're gonna call this thing equal to u, and then I'm gonna say that 1 over x squared is equal to dv. Right? I think that looks like a good
Why
idea.
is it whenever it's square?
Because it's got to be u dv. So how integration by parts works, which is like kind of the reverse product rule. It's kind of cool. U
I
dv
don't know where your whenever it's.
equals uv
Same.
minus the integral of v to u. This is how it works.
Yeah.
So I'm gonna say that u
Yeah.
is equal to the ln of x plus 1. And that dv, well, that has to be this whole thing here, which is 1 over x squared dx. X plus 2 squared dx. You see that?
So you said it then was the part division. Okay.
Oh,
And
yeah.
then
Yeah, okay. Yeah.
how do you say it?
And then I'm gonna take some derivatives, right? So du is equal to 1 over x plus 1 times the derivative of this, which is just 1, dx. And then dv, if we integrate that, that's going to be equal to negative x plus 2 to the negative 1. And I think that's it.
That's his day.
Because this is the same thing as x plus 2 to the minus, or to the minus 2, which is like u to the minus 2,
Yeah.
which then becomes u to the negative 1 over negative 1. But then the derivative of this is just 1, so we're cool. Yeah.
Yeah.
Nice. We're doing a little u sub in our head this time as well. Okay. Cool. Does that make sense, Spirit, so far? What we're doing, like how I went from here to here? That's kind of fast sometimes, I know.
Yeah.
Cool. All right, he's all Gucci. All right. So that's equal to uv. So that's negative 1 over x plus 2 times the ln of x plus 1 minus
We can collapse that.
plus.
before we move
Yeah, we
to
will. I will collapse in a second. Minus v is 1 over, so minus 1 over x plus 2. And then du, so then that's 1 over x plus 1. Oh, ew, is this fucking partial fractions? Is it? That's fucking gross, dude. God damn it.
Like,
No. No.
No, God!
Do you not expect that?
Yeah, I know how to split it. It's okay. All right. All right, so we got to split this now because these are two factors on the bottom. So I'm going to say 1 over x plus 2, x plus, or you, yeah, sorry. He wants me to condense this just to make it nice. There you go. Is that okay? That look better? Well, oh, fucking things up.
No.
It's like, no.
That's,
No.
that's
There we go.
no.
That's better. That's better, right? Okay. This is equal to this. Oh, sorry. This is equal to a over x plus 2 plus b over x plus 1.
Yeah.
So then what we do is we multiply each thing by the factor that's missing. Multiply this by... And then what I get is that 1 is equal to... or no, sorry. What do I want to do here? Okay, sorry, my bad. So this is ax plus a
That's A.
plus bx plus 2b all
is one.
over x plus 2 x plus 1 is equal to 1. 1
No,
over
one
x
over the
plus
bottom.
x plus 2 x plus 1,
And
right?
bottoms cancel.
So now the bottoms cancel. Okay, cool. Yeah, got it. All right. That's what I meant. Okay.
We need to do that
So
and happen.
1 is equal to, let's say, a plus b times x plus a plus 2b.
Yeah.
So since this has no x term, that means that this must be equal to
Is it-
0. So a plus b equals 0, so a equals minus b. This has to be equal to 1. So a plus 2b is equal to 1, but a equals minus b. So minus b plus 2b is equal to 1. Minus b equals 1. B equals negative 1. A equals positive 1. Okay.
And rewriting this. We need.
So I can now rewrite this whole thing. Let's take her down.
Yep.
This is the same thing as the integral of 1 over x plus 2 minus the integral of 1 over x plus 1.
Yep.
Cool.
And you forgot both of those.
dx.
Is it
dx.
of what?
Sorry, what?
You did. You got it.
Okay. And then this is just ln of x plus 2. So we have negative ln of x plus 1 over x plus 2 plus the ln of x plus 2 minus the ln of x plus 1. Oh,
And
man.
we can simplify this.
I do, but do I want to combine this with this? Or no, I think I want to combine these one. Wait, plus b is 1? Did I fuck up? I'm sorry, boys. Wait 1 sec.
Did you?
I might have.
No.
A equals minus b.
No.
Yes, no, I did screw up. My bad.
You done messed up, Aaron!
Oh man, I'm messed
I
up.
just said just-
It's b
just
equals
shut up.
1, not b equals negative 1. Thank you guys. I appreciate that, chat.
Oh, yep. Now
Chat caught me.
now I
Chat
do.
caught me. Chat caught me. Okay, cool. There we go. Whatever. Plus. Yes, negative b plus 2b is 1. Yeah, it's not
And
negative
that's
1. My
part.
bad.
That's part.
I was just trying to speed run it. Okay, so this is minus, this is plus, which means I'm going to move this around. And now I'm going to
Now,
call this
we
whole
could-
thing x plus 1 over x plus 2. Right? And then we're going to say minus 1 over x plus 2 ln of x plus 1. And I think we're good. I mean, if I really
I
wanted
would've
to, well, if I really wanted to,
No,
right?
mm,
We
no.
we
I don't
can
like
get
that answer, though.
You don't like it? Why not?
No, I'm gonna add 1,000 to that answer. I'll still be right about it.
Okay. I could think this is also the same thing as like x plus 1 to the x plus 2 root. I don't know if you really want to be like gross. Like technically that's right.
Finish the problem.
Plus C. Plus C. God damn it, plus C. God damn it. Alright, whatever, we did it. Yeah, congrats. Yeah, that's why you could add 1,000 to it.
One case.
Yeah.
You want to do the parallel expansions then?
I actually have to go teach another
Or
student.
the
We
road
went over time today, but
Yeah, I know we did. And that
That's
was
all
a
good. I had
idea,
some I had some fun with them.
You never said you had a student to go to, so.
I know, but I forgot. And now I'm noticing I have to go in like 5 minutes. Okay, cool. Let's end the stream. Thank you everyone for coming in Actual Education Office Hours. Really appreciate everyone submitting their questions, asking for help. Y'all in the chat being awesome. If you're watching us on YouTube, please like, subscribe, all that fun stuff. Helps us out to get more out there on the algorithm and more people find us, and then we can help more people. Okay, our next stream is going to be... So actually, I do have a stream tomorrow, but it's for AP Physics 1. So I apologize if you're asking about any other class. Tomorrow is dedicated to me reviewing for the AP Physics 1 exam, which comes up on Friday. So I'm doing a review for all the high school students on Thursday, which is tomorrow.
Do well. Hope they do well.
I hope they do well. Yes, good luck to them. So you're more than welcome to come by and learn AP Physics 1. Just I won't be able to answer any other questions unless it's AP Physics 1. So
And Dead or Old. Say to the people too tomorrow. for for everybody taking the AP Physics 1 exam, good luck.
Yes, good luck. Good luck, everyone. I agree with Seth. But yeah, if you want to figure out any time we're streaming, there's a calendar here. It's calendar.actual.education, which here, I'll put it in the chat for you guys as well. So there's the calendar. You can figure out when people are streaming. So yes, we're streaming tomorrow at 3:30 Pacific. So that'll be 4:30 Mountain, 5:30 Central, 6:30 Eastern. Also, Zach, E2I is doing a math stream tomorrow morning at 9:30 my time Pacific. So yeah,
It's software though. No.
Well, no, it's math plus math education chat plus software development. It's kind of, I think, a more, I mean, Zach can answer it, but I think it's more of like an open format stream he has. So
Yeah, one of his.
yeah, if you want to ask math questions, I'm sure he'd be more than happy to answer them. Go on by tomorrow morning and hit him up. Okay.
Anybody's live in the math.
Yes, let's go raid somebody. Because that's what we do here.
I don't see who we're looking for. I was looking for the person who's been live.
Wow, 1601 followers. We hit our goal. That's super dope.
No, Obi didn't. Obi's already offline then. Obi's offline already.
Oh, Obi rated us.
Oh.
Who am I following? Who are we gonna go send our viewers to?
I have nobody on my side. So.
Merriweather is doing something. Dude, let's go say hi to Merriweather. I don't know what he's doing, but it looks this looks like circuits. Please go ask Merriweather what the hell he's doing. All right. Anyways, yes. Okay, awesome. Have a wonderful rest of your Wednesday. Thanks everyone for coming by. Good luck on any of your tests you have tomorrow, this weekend. Feel free to join the Discord if you want more help while we're offline. And peace out.